without further ado, I'd like to bring up the founder of Digital Shovel, Scott Johnson. Scott.
Can you guys hear me? Who knows anything about cryptocurrency mining at all? Couple? Okay, great. Awesome. So my name is Scott Johnson. Like you said, I founded Digital Shovel. We specialize in cryptocurrency mining in particular. We build shipping containers that are basically data centers inside a shipping container for turnkey operations as well. We do a variety of hosting solutions. Today I'm going to talk about different cryptocurrency mining technologies, the evolution of a couple different technologies, and pros and cons of the different types of cryptocurrency mining technologies. The simple part, we're going to predominantly talk about proof of work. So proof of work is trying to solve a cryptographic hash. I'm not going to get too granular on that, but basically there's no reverse engineering way to do it. You simply need brute force to put a possibility into an equation to try and get an output which matches your target. And there's a variety of technologies that can do that in a variety of different ways. So which one is the best? There's a whole bunch of different things to consider. One is the equipment longevity. So how long is the equipment going to last you? If you buy this piece of equipment, are you going to be mining for 6 months with it, like some of the Sia coin miners? Or are you going to be mining for 2 years, like some of the S9 miners? Or is it something that, like a GPU that has versatility that's going to allow you to mine for a lot longer time? Another point of consideration is the difficulty acceleration rate for that particular algorithm. So if you're focusing on a particular coin, like Bitcoin for instance, the equipment you buy for that can only do that purpose. So you have to look at how quickly that difficulty rate is going to accelerate and how quickly your equipment potentially can become obsolete, which I'll get into more in the future slides. The other obviously is the cost of how many hashes you can do per second per dollar spent. The more hashes you can do, the more competitive you are, the more money you make. Flexibility, and I made up a word called reversibility today. Not a word. In terms of what the equipment can be used for later. So if you're not married to that purpose, in other words, if you think maybe you're not going to be cryptocurrency mining forever and you want to use the equipment for something else, that might fall into your decision-making process in terms of the type of equipment you're going to purchase. And then currency speculation, where you think the coin is going. I'm not a big fan of that mindset, but if you're buying an ASIC or something that's specific to a certain coin, you really are married to that algorithm and where the currency speculation is going to go off your potential yield if you're going to be holding that coin. So right now there's 3 different main technologies. We started with originally CPUs, quickly moved to GPUs. The Bitcoin crowd moved very quickly to FPGAs and skipped that step and moved into ASICs. So GPUs is a graphics processing card or graphics processing unit, similar to what you use to play video games or do high-end rendering of videos or computer graphics. An FPGA is a field programmable gate array, which I'll get into a lot more in a second. And then an ASIC is an application-specific integrated circuit. Fancy animations. So first on field programmable gate arrays. They've been around for a long time. They were used a while back for Bitcoin mining. People seem to have forgot about them, but recently they picked up in popularity specifically for Ethereum and other altcoin mining. An FPGA, as it's called, is basically it's a chip that can be used to design other chips. So say you're going to design a GPU or you're going to design an ASIC and you want to test how that logic works when it's programmed to act like a chip. It's very, very expensive to print a chip, like incredibly expensive. So before you do that, you want to test that potential structure, and you can buy one of these FPGAs to do that. They used to range in price from $4,000 to $12,000. You can get a skinny version for $1,000, and some were dramatically more expensive. They've come down in cost, and people are now using them as a method to accelerate past what GPUs are, and actually use them in conjunction with GPUs, which I'll get to more in the next slide. Some of the pros, obviously, have algorithm flexibility because you can reprogram it to something else, and you can reuse it for another purpose, like AI. It has rapid memory access rate because you can actually create a memory operation on the chip rather than having to go through a PCI bus to access your memory. And high-speed sequential processing, which I'll get into more in a second, but that's one of the bottlenecks for GPUs. They're really good at parallel processing, but not really good at sequentially doing a whole bunch of different things. And after I got one wrong, I tried the next one. That's sequential processing. Some of the cons, obviously they're high cost, limited consumer reuse applications. You can reuse them for other things, but unlike a GPU, it's a relatively niche market that uses an FPGA. And then difficulty programming them, so it's not an easy thing to program machine level code. Whereas if you're working on FPGA or something like that, it's significantly easier. Graphics processing units, more fancy animations. Pros and cons. Obviously, algorithm flexibility. Multiple reuses, you can use them for video editing, playing video games, watching 4K porn, whatever. High parallel processing capacity, meaning you can send multiple operations to it that has a whole bunch of subcores within one core, meaning if I wanted to solve 10 different puzzles and I wanted to solve them all at once, I can send them out to different subcores within that processor, and it'll solve them in parallel rather than having to wait for one operation to happen after another. The cons is now they're beginning to have very low hash rate compared to other things on the market. Risk of becoming obsolete because of all the other options on the market. And then relatively low power efficiency. So a single card that might do 20 mega hash are going to consume 160 watts of power compared to what an ASIC can do that's less than 10,000s, less than 100,000s in terms of hashes per watt consumed. And the last here is ASICs. So application-specific integrated circuits. Bitmain has been on the forefront for that. There's other companies like Silicon, Bitfury, a couple other smaller ones, but those are kind of the three really large players. Pros, extremely high performance, high power efficiency, and it will heat your house. Anybody have an ASIC monitor here? Yes, you know what I'm talking about. Cons, zero flexibility. Once you print an ASIC, you can now go back and change it. You can create a firmware upgrade that can choose how the control board is sequencing towards that ASIC, but how your ASIC operation is working on that actual chip cannot be changed. Obviously, as a result of that, you have a risk of becoming obsolete. And then there's zero additional use cases unless you want to perform a hashing algorithm with that same process. If you had some other use case, in the case of the Bitmain device for the SHA-256 algorithm, you could use it for that. However, if you're going to do that, you would just go buy a new piece of equipment because it's going to do it more efficiently than your old piece would do it. 7 nanometer. Anybody heard about what's going on with 7 nanometer chips? A couple? Sweet. So, when you hear the term 7 nanometer, we're referring to how big the transistor is on the printed circuit. To put it in comparison, most of the stuff on the market right now is 16 nanometer. I think Silicon stuff is like 12 nanometer. There's a Japanese company that did 7 or 8 nanometer a couple months back. Bitmain has now announced they're coming out with 7 nanometer. The smaller your chip, the higher the density, the higher efficiency. The more hashes you can do per watt spent. The less you spend on energy, the higher your return is going to be, the more money you're going to make, and you're going to move quicker, alluding to my friend's terminology earlier. And even more exciting, FPGA boosted GPUs. So this is a relatively new technology that's coming out. A company called Acorn is developing one that they claim is on the market. Another company out of Toronto called Epic is in the process of developing one as well. What it does is it uses the benefits earlier that I was talking about of FPGA, and it moves the sequential operations off the GPU. So it uses the GPU for what it's good at, parallel processing, and then when the bottleneck work is waiting on sequential processing, it moves those processes onto an FPGA. Very low cost for modification. They can actually take it and put it into an M2 slot. Those are those tiny little memory card looking slots in your motherboard. So you don't have to modify your whole rig. You don't need to go put in a new case or anything like that. You can, most times, modify your existing rig in order to make this work. You're going to get a power decrease in terms of consumption. You're looking at somewhere, depending on the setup, between 10 to 30%, and you're looking at anywhere from 5 to 10% increase in hash power. Now, while the increase in hash power is not significant, power is a very big thing. In the case of Ethereum money right now, if you're a commercial operation in Ontario, you are not making any money at 18, 17 cents per kilowatt hour. Unless you have an incredibly efficient card, but for the most part, you're not terribly efficient, or you're making 2-3%. So that decrease in power consumption makes a very, very big difference. So what's best? Nothing's best. It really depends on what you want to do, what's good for your risk profile. So you want to choose equipment that is in line with the same way you would pick a cryptocurrency. Like when you're deciding to buy, you're deciding you don't want to go buy the currency directly, but you want to pick a derivative of of that currency in a way. So you want to look at what your risk tolerance was in terms of purchasing a cryptocurrency and kind of apply that to your equipment. Do you want something that has potential risk of becoming 100% obsolete and having a really high return? For instance, like the Z9 miners right now that mine Zcash, the returns are ridiculous, but they could be rendered obsolete very quickly. That goes back to the increase in difficulty factor I was talking about earlier. Although Zcash is a relatively low hash rate in the grand scheme of things, the returns are really high, but somebody might come out with a new efficient piece of equipment and render your entire investment obsolete. So you have to really look at what your risk tolerance is when you're deciding to pick your piece of equipment. Mine platform you believe in. But as much as I like to make money and most people like to make money, it's important to support good projects and help good projects move forward, not just because it's the best project or the coolest project. Well, maybe because it's a cool project, but it's the best in terms of return. It's good to support good projects, and that's something you have to make that decision yourself, whether you're just in it for the money or you're in it for the betterment of the future. Genesis coin mining. So this is a kind of an interesting philosophy. So what you do is you try to find cryptocurrencies that are not yet traded on an open market, or if they are, there's very little liquidity. As a result, there's very few people mining it. You can get in, you can mine this coin very quickly, generate a lot of coins, and then when it gets liquidity, when they decide to put it on CoinSmart, you end up making a boatload because the price goes through the roof. I'm not a big fan of speculative coin mining, where you're mining coins that are already on a currency, hoping for it to go up, which I'll get into more in a second. But this is referring to when a coin isn't really liquid in the sense that you can't go and openly trade it. You know something about that currency that you think is going to result in it going up in value when it goes to the market, and you can mine it for that reason. Do your research, like you alluded to earlier, read the white papers, know the projects before you actually start spending a lot of money on whether you're mining or investing. What not to do? Like I said, speculative coin mining. There is no reason for you to go and mine a coin while it's down, thinking it's going to go up later on. Go mine the coin that makes you the most amount of money with that particular piece of equipment, and then go buy the other shit coin if you want to, if that's your philosophy. Because you're going to end up with more of those coins in the end run, rather than just mining the lower value coin in the first place. Unless, of course, you're doing it because you support the part of the technology, which is a different story. Don't mine when you're underwater. Like, there's a lot of guys right now in Toronto that I know that their equipment is not efficient, that continue to mine Ethereum while they're losing money. Saying, oh, the coin's going to go up later. Don't take the money you're going to spend on electricity and go buy Ethereum directly. You get a higher return by doing it that way. Cloud mining. Nobody ever really made a lot of money cloud mining, if any money whatsoever. Cloud mining is good for learning the technology, learning how to set up a wallet, learning how the pool works. So if you want to learn it, take it as a less expensive lesson than buying equipment that goes obsolete, sign up for a cloud account, learn how the process works, learn how the wallets work, learn how the pools work. It's a good way to understand the technology. It is not a good way to make a return on your investment. And don't mind BCH.
Is that 20% good?
Still don't mind BCH.
Thank you, Scott, very much.